Alright, let's get started. You might notice a change of scenery. I just moved into my campus apartment just today, so it's been a bit of a long day, but in any case, let's get started with our LeetCode. The first problem is going to be LeetCode number 179, largest number. Given a list of non-negative integers nums, arrange them such that they form the largest number and return it. Since the result may be very large, you need to return a string instead of an integer. Okay. I think I've seen this before. Because this was one of the medium problems on the binary search group that I'm in. What was it? I think it was a sort of greedy approach to it, where you start by sorting by the first number or the first digit. Then you continue by sorting by the second digit. The idea is that the first digit, 0 through 9, will produce the largest number regardless. So for example, in this case, 33, 30, 34, 5, and 9. The largest number here, or the one that you should lead with, is 9 as a digit. So you start with that one. But there's an additional case where if you have numbers like 90, let's say like 95 versus 98, right? In this case, you want to do 98, 95 because that's greater than 95, 98. So you want to sort by the second digit in the case that there are ties, right? Let's see. In that case, let's suppose that this is the algorithm that we actually want to do, right? So we want to sort by the first digit, and then we want to sort by the second digit. How do we approach this in an actual proper algorithm? Well, we want to sort by the first digit. And what we could do is that we could convert to string, then compare the first number as a character. And the reasoning behind this is that because ASCII goes 0 through 9 in increasing order, then 9 will naturally be greater than 0, even in character form. So that's why this works when we can turn it into a string, turn each integer into a string, and then compare each string using their actual character values like that. How do we sort by the second digit? Well, we need to have a way of bucketing numbers with the same character, or with the same first character, right? And we could do this using a hash map, which will map a character to a list of strings, right? And the idea is that if they all match a particular first digit, such as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, well, realistically, 0 shouldn't be part of it, right? But 1 through 9, then we'll add them to the list. And then internally within those lists, we will sort them. And I guess actually what we could do, let's see. We have numbers 1 through 9. We have digits 1 through 9, and then another set of digits 1 through 9. I'm thinking of what if we decided to do something like we had a hash map that has a character and then a list, or rather a hash map that goes with a character key that goes into another hash map that then goes into a list of strings or something like that, right? Like the general idea is that we want to have two buckets, first digit and second digit, in order to facilitate our sorting. Then we build up those characters, or build up the string from those characters, right? And that might be possible. What would that data structure look like? It would be a hash map of character into, we will say, we could probably do almost like a sort of bucket sorting on our own, right? Honestly, yeah. We could have an array of strings, which is of size 8, where each string or each array represents that particular digit as 0 indexed. So actually this should be probably a size 9, right? Because it could be 0 or no value through 9. Let's see. Let me think about this some more. I guess the main problem that I'm thinking about now is whether or not this extends to more digits beyond the first and second digits. Right? So if we had a number like 123 versus 124, of course we would want 124, 123 versus 123, 124, right? So it seems like we need to sort of we sort of need to bucket them into as many digits as possible. But how then do we go about doing that? How do we go about doing that? We could potentially utilize get or null. And if it's null, then we'll count it as 0. And that is one way to compare them. But then there will be, so then all comparisons will be of length L, where L is the largest number in terms of digits, right? So the longest number, that will be the sort of bounds for our algorithm, because we'll need to compare every single number to that extent, to the number of digits that the longest number has. Is there a better way of doing this? Let's see. Each number goes from 1 to 10 to the 9. How many digits are there in 10 to the 9? That's a good question. Because we would technically need all of those layers, right? And that would be a lot of data stored. I'm not sure if I want to go about doing that. But how do we, I guess the main thing is now it's like, how do we apply this logic across all values without it slowing down? And I'm not sure if there is a way to do so. Let's see. I guess to a certain extent also the idea is that we only want to sort the second digit among all numbers where the first digit is the same, right? We don't want to touch the other digits, or we don't want to touch the other numbers where the first digit is not the same. So if we did an O of n log n, this which is sorting by first digit, we would then need to do essentially, what would that be? Like if we partitioned each section, to be in the way that it's meant to be, among its own first digit numbers, and then we sort that. Well, let's suppose that that encompasses the entire array, and this would be O of n log n again, to sort by second digit, assuming all start with same digit. So this would be like if we had like 999, 998, 997, right? And then so on and so forth. So this would be O of L times n log n, where L is, like we said, the largest, or the number of digits in the longest number. I think that makes sense. The question really is, how do we make sure that we're partitioning within our own numbers? I'm still thinking about using a hash map, but is a hash map necessary? Because we only really want to sort a subsection of them, right? And how do we do that? If we did our initial thing where we did a hash map a character into a list of strings, we get all the values that share the same first digit. That is true. But then we need to sort that collection essentially by their second digit and create another sort of layer, right? And how do we do that in a way that makes sense? Well, of course, if there are no layers, if there are no additional items added, like if there are no matches, so all of the digits within or all the numbers with a shared digit are done. Like for example, if we go to 999, 998, 997, if we cross a line on these three, then all the shared digits are gone, right? If there are no matches, then the bucket is as it is, and we don't need to worry about it any further. hold on. But again, I'm not sure how we can handle like nesting in the digits further. So we can get started with that at the very least. So we can say val map. We'll say digit map is equal to mutable map of. This will be a character to a mutable list of strings. And for each num, we'll say num as string is num.toString. And if digit map get num as string at 0 is not null, then we want to put inside or we want to get the list, so digit map get num as string at 0 as a mutable list of string. And then we can say list add our num as string. Otherwise, we want to digit map put into there, into our num as string at 0, which is our starting character. We want to create a mutable list of strings, which include the num as string as our first value within. So we can do a print line on our digit map and see what this returns. And let's just do a return blank string first, just so we can sort of see what's going on. So this test case uses 10 and 2. This should be mutable list of, not just mutable list. Yeah, so we have 1 is equal to 10, 2 is equal to 2. So that's working out properly. And we can do something like, let's run the second example. I think that provides like a better sort of test case to make sure that everything is working. Yeah, so for 3 we have 3, 30, and 34. And then we can say digit map for each entry. We can say entry.value.sort sorted by let's see, sorted by it at get or null at 1, or we count it as 0. So this is sort by second digit, and this is partition into first digit. I'm not sure sorted by is the one that we want. I recall using that lambda, but I'm not entirely sure if that's what we actually want now. Sorted by let's see if get or null 1 works. Or maybe if we just do entry.value.sort here. Because I think lexicographical does it actually, and I think we need to do it backwards. Is it sort descending? Is that what we want? Okay. And then we want to sort of go through each bucket, starting from 9 all the way down to 0. So for number in 9 down to 0, if digit map get number is not null, then for number and we can do like a val return string is equal to string builder, and this is just a default string builder. And we can do a digit or val list is equal to digit map dot get number as, we can do a regular list string and then list for each item. We want to just do a return string dot append our list or our item. So this will go through our list and add each individual item all the way from 9 down to 0, assuming that they exist within here. And then we return our return string dot toString. So this is just creating the string from each major bucket. And then within each bucket, it is sorted by a second digit. Let's see. 30 is larger than 3, which is a problem. So I might need to do something different. Let's see. I might need to create my own comparator. And that would be a class, let's say compare largest number, which extends our comparator on our character. And we need to override the function compare to. And this will be other, which is of type character. And this will say return when if, let's see, if our current value is null, or is it the other value is null? Let me see, comparator. Because what happens when things are null? Oh no, it's compare is what we want. I don't think it's compare to. So if we're comparing character by character, and we say first, which is a character question mark, and the other, which is a character, also a character nullable. Or can I just get the character? Can I just get the character as? I can't grab the comparator of a class. Realistically, what I want is a comparator. Is a comparator of the character, and then get the nulls first, or the nulls last version of it. But I'm not sure if that's possible. So let's not worry about that. Equals compare. Yeah, I'm not sure. Maybe there's a smarter way to deal with this, but I'm not too sure how to deal with, like, in a smart way to deal with this right now. So, I guess when first is equal to null and second is not null, or first is not null and second is null, and this should return an integer. When one of them is null, then if second is not null and if the second value is not null and it is greater than 0, let's see. If it is not null, in what circumstance would it need to be greater? If we had 3 and 3, 4, would we want 3, 3, 4 or 3, 4, 3? We'd want 3, 4, 3. So, suppose we had two numbers, 34 and 3. Well, we don't know which one is larger. Ideally, we want 343 because it's larger than 334. But we also don't want to just say, okay, the number that is larger, or that has the second digit, goes first. Because, like we said, for 30 and 3, we want 330, which is greater than 303. So realistically, what we want is that we want to compare the second character with respect to the first character. And we know that the first character is always going to be we know that the first character is always going to be within the bucket. Like we know what it is, right? So maybe in that case, maybe we use something from Kotlin. This is let's see. In that case, specified selector function. Okay, I'm gonna take a bit of a crack at this and then I'll be right back. Okay, yeah. Sometimes it's the obvious answer that's right in front of you that is at least the stepping stone to the proper answer, and I think I should have thought of that before jumping to ideas from other places. In any case, let me walk you through the solution. It's pretty simple. You compare, given any two strings, you try combining them one way or the other, and you see which one is larger using the standard library, and you pass that in as a comparator. There's an edge case where if you have all zeros, then you just want to return 1 0. And in that case, I'm just using a check here to see if the sum is 0. Since our input is relegated between at the least 0, we don't need to worry about something like a negative number or anything getting in our way. So we can just use that as our check. In any case, we turn them all into strings. Then we sort them with our custom comparator. And then after that, we just concatenate it all and return that. In any case, yeah, so that's the straightforward solution. You just concatenate and you see using the standard library to see which one is larger. It's pretty straightforward, actually, but just I suppose, not entirely intuitive. It's an interesting question. Definitely need to come back to this one. In any case, this is just sorting in terms of runtime O of nlogn. In terms of space, it's O of n because we need to store all the elements within as a string form within our list before returning them. And in any case, I hope you learned something, and I'll see you for the next video.